3 will be going over how to do problem 2 in exam 3. Part A asks us to find the inertia of the assembly, the information of which I've written on the board already. And we see that the total inertia is just equal to inertia of both of the parts, the sum of it. These two we can find by realizing that they're being rotated around a parallel axis, so we can apply what we know about the parallel axis theorem. According to the table, for the rod, this ICOM would be 1/12 times its mass times its length squared. Its HCOM would be its length over 2. For a disk, the table tells us that it's 1/2 times its mass times its radius, which is just its diameter over 2. Its HCOM would be this location, which is, it happens to be its radius plus the length of the rod, which is 5 over L, 5L over 4 squared. And we will be able to solve for these and find out our final inertia would be 217 over 96 ML. Let me check if that's right. Yep, it's 217 ml squared over 96. Now for B, we're being asked to find the minimum speed it can have in order to make one full loop around. For it to make one full loop around, it has to barely make the top. When it barely makes the top, its omega would be 0. This is an indication that we need to use work energy theorem. Problem says there are none here. Its kinetic energy would be 1/2 times the inertia from part A, omega squared, minimum omega squared. What's its potential energy? Well, we know that gravity acts on its center of mass. So if we call its center of mass at its lowest point 0, that means that its highest point is going to be twice its center of mass. How do we find its center of mass? Well, we know that center of mass is equal to the sum of each of the masses times the location of their center of masses in the y-coordinate. If we put a coordinate axis, this is the origin and this is positive y, over its total mass. You can pretty much figure out from what I said for the previous center of masses and the previous masses to be able to find where the center of mass is. Well, I'll just order the answer to you and give you 3/4 times L as its center mass. That means its final height is going to be 3/2 L, which means that the total mass of the thing times gravitational constant times its final height is going to be the final potential energy. And none here because its height is 0 initially. No kinetic energy either because of what I said before about omega being 0 at the top. Then you would find the inertia, use inertia from last time, and then you get that answer to look like so. Part C asks us to find the force of the axle when it's at its lowest point. Let's draw a free body diagram. There's going to be gravity acting on its center mass. This is the axle. We don't know where the force of the axle is pointing at, so we need to use trig to find its x and y components. If we call this theta, get that this is equal to f sine theta. That's f of x, by the way. Fy is equal to f cos of theta. It's circular motion, so tangential acceleration and radial acceleration are going to be in this problem. We'll call this positive y and this positive x. It doesn't matter. So we find that, let's sum up the forces and use Newton's second law. This acceleration is going to be AT. But how do we find tangential acceleration? Well, we know that tangential acceleration is derived from radius times angular acceleration. Angular acceleration can be applied by summing up the torques and equating that to inertia times angular acceleration. Is there any torque though? Well, the force of the axle is acting on the axle, so there's not going to be any torque from the axle. It's not going to be any torque from gravitational force either, because the angle between that force and the radius is going to be 0. So we end up getting an angular acceleration of 0, which means that this is equal to 0, which means that there's no x component of the force of the axle. Is there a y component? Well, if this is tangential acceleration, that means the y component must be radial acceleration. So 3MAR is going to be equal to the force of the sum of the forces, which is F cos of phi, which is F of y minus 3mg. We'd solve for AR by knowing that this is equal to omega squared r, where omega is omega minimum, and r is equal to the center of mass, which is 3/4 L, and you would find that your final answer would be, if I can find the page for it, f of y is equal to f, which is equal to 3m, this being part B's answer, r being 3/4 L plus g in plus y direction. That's our answer to C. Now D is a lot more complicated, even though it's asking us to find the same thing, because now it's going to be horizontal and halfway up to the top. Instead, sure, FBD, I don't really need to explain anything here, except for that the tangential acceleration is going to point in the y direction, and radial acceleration is going to be pointing in the positive x direction. Let's call this, let's call it clockwise positive, because that's where it's spinning. It's going to act at center of mass. And force of the axle, we don't know. Let's use trig again. And let's sum up the forces. I already told you how to find tangential acceleration and how to find omega. So let's look at the sum of the torques. Well, in sum of the torques, this time there is going to be torque from gravitational. Because there's a distance separated between where the force is acting on and the axis of rotation, which is the center of mass. So that's solved. Now let's find radial acceleration, which is what we're going to need to use to find the y component of the force. Remembering that it's derived from this and knowing that it's going to have a different omega horizontally, we use the work energy theorem, where the final height is half that of the final height in part C. And we solve for AR, and then you'd find you would solve for F individually, and you're gonna have a bunch of unknowns. Then you would set them equal to each other so you can find the angle, and then the angle is 9.63 degrees above the positive y-axis. Positive x-axis, my bad. Then you plug the angle back in, and then you would solve for F itself, which is just 4.54 mg. That's your answer for D. Thanks for watching.